Welcome Pure Maths 3 students to week 10 of our maintenance. We've got quite a few questions today. Starting off with an algebra question. This is a past examination question. We're trying to split or express this in partial fractions. Now, given the bottom situation here, what we're looking at is we're trying to get a over 3 minus 2x. Whoops. 3 minus 2x. Plus b over 1 plus 2x plus c over 1 plus 2x all squared. Okay, that's how we'd split that into partial fractions. So what that means is that if we want to have them all having the same denominator, a would have to be multiplied by 1 plus 2x all squared. And if we wanted the b to have the same denominator as the other two, we'd have to multiply it by 3 minus 2x and 1 plus 2x. And then the c would only need to be multiplied by the 3 minus 2x, so that they've all now got the same denominator. And when we do that, that should make our numerator. Okay, because you see here we've got one denominator, so to get one denominator from the red fractions here, I would have to multiply them so they have the same denominator and then do that same thing to the numerator. So my numerator would be this blue that I've just written here. Now what we do with these is we're just going to say, well, let's let x equal oh sorry, it's not 3 minus 2x, it's just 3 minus x. Let me just fix that up. 3 minus x, I don't know what happened there, just not looking carefully enough. 3 minus x, 3 minus x, 1 plus 2x. Okay, I think we're right now. Let's let x equal 3, because you can see that if x is 3, this will become 0, and this will become 0, right? And then that will, 0 times anything is 0. So if you let x equal to 3, then you'll get just the a left over. So pop a 3 into here, we get 2 times 3 is 6. Plus 1 is 7. 7 squared is 49. So we get 49a is equal to, now we put 3's in here, and that's 4 plus 12 times 3. 12 times 3 is 36. So we're on 40. And then 3 squared is 9, so 49. Okay, so 49a equals 49. So a is equal to 1. So that's our first finding. Now what we can do is we can look at b. So we know that if a is 1, when it multiplies by this, you're going to get a times 4x squared. And then the only other way that you can get a x squared term is b times negative x times positive 2x. So that ends up being not plus but minus 2bx squared. And that should give us x squared, which means that 4a minus 2b ought to equal 1. Now that means that b is equal to 3 over 2, because negative 2 times 3 over 2 is negative 3, and 4 take away negative 3, because we've already found that a is 1, right? So this here is actually just going to be 4. 4 take away negative 2 times 3 over 2 is 1. Okay, so that's b. That's called equating the coefficients. I used my knowledge of how many x squared terms I have here to help me find that last one. And then for c, all I need to do is just plug in, let's see, I could let x equal negative 1/2, and what will happen here is that'll cause these ones to drop out, right? Because 2 times negative half is negative 1, 1 plus negative 1 is 0. 0 times anything is 0. So that will drop the a's and b's out. And that will leave us with 3 minus a half is like 3.5c, isn't it? Equals, and then we insert into this side the negative 1.5, and we get, what do we get? 4 minus 6 plus 1/4, and therefore we find that c is equal to negative 1/2. So that's the first one. That was a little bit of a tricky partial fractions one. Now we've got to obtain an expansion. Okay, so for what I'm going to do for this, I'm going to actually change colour of pens so you can see what I'm doing here, because I'm going to need more space. So in actual fact, you can see that what we've got is the first fraction, a over 3 minus 2x, is 1 over 3 minus 2x. Now, then the second one, b, is going to be 3 over 2, so 3 over 2 bracket 1 plus 2x, like that. And the third one is actually minus, because c is negative 1/2, so 1 over 2 bracket 1 plus 2x all squared. Now, that's what we're expanding. So I'm going to start with this first one here. Another way of writing that is 3 minus 2x to the power of negative 1. And then I can't expand it like that, so I've first got to take this 3 out. So that's equal to oh, and it's not 2x. Why am I writing 2x all of the time? Oh, I wrote it over here. I see. There we go. That's x. This is not x. This is x here, right? And it's not 2x there. Sorry, guys. Brain, wake up. So in that case, when I get to this point, I ought to have 1 minus x over 3. Now, see, what you want to do when you're expanding these negative powers, you want to have this number here as a 1, not a 3 or anything else. It's got to be a 1, so you can factorize out by timesing everything by 3 to the minus 1. Okay, now when we expand this, we're going to get 3 to the power of minus 1, and then I'm just going to pop my big square bracket in. We're going up to the term in x squared, so the first term is 1. The second term is plus negative 1, so we take our power, negative 1, we multiply it by our x term, and that's to the power of 1. Then the next one is going to be negative 1 times negative 2, so we drop do the first power, minus 1, drop it down, times it by that, negative 2, put it over 2 factorial, and we're now timesing by negative x over 3 all squared, and that's as far as we need to go. So we can simplify that to 1/3 1 plus that second term there is going to be just x over 3. The next term is going to be plus, what is that? X squared over 9. And we can therefore say that all up we've got 1/3 plus x over 9 plus x squared over 27. Okay, so that's the first one expanded. Now the next two are somewhat easier, so we're going to now try this one here. So that is like 3 over 2. See how it's already got that 1 there, so we can start expanding it straight away. You can write it, I guess, first as 3 over 2 into 1 minus plus 2x all to the power of negative 1, and then we can just simply expand. So it's 3 over 2 bracket 1 plus minus 1 into 2x plus, and then minus 1 times minus 2 all over 2 factorial 2x, and that's all squared. And that's as far as we need to go because we're only going up to our squared terms. So when we expand that, we get 3 over 2 minus 3x. Now this last term, it's going to be positive 4x squared, and then we times it by 3 over 2. So that's 12 over 2, so 6, so it should be plus 6x squared. So we've done that one. The last one that we need to do is this one here. So I'm going to do that over here. Minus 1/2, and it's times 1 plus 2x, and this is to the power of negative 2 because it's squared at the bottom of the fraction there. Now, my next line, I'm going to say 1 over 2 bracket 1 plus minus 2. This time the power is minus 2, so minus 2 times 2x. And then the next term is going to be plus minus 2 times minus 3 all over 2 factorial into 2x, and we're going to square that whole thing. And that's as far as we need to go. Now when we expand this, we get negative 1/2 minus 4x plus, I think it becomes plus 2x. And the last one is, let's see, 3 times negative 2 is positive 6 over 2 factorial is positive 3 times 4x squared, so 12x squared times minus 1/2, so I think it's minus 6x squared. You might want to do more steps. I'm just running out of room. That's why I'm kind of cutting this back a bit. All right, so now we've got our 3 expansions, and so we've got to just add everything together. So let's look at our first term. So we've got 3 over 2. We got 1/3. And we got negative 1/2. So all up, that looks to me to be, is that 4/3? So 3 over 2 take away, yeah, 4/3. So 4/3. And then we look at the x terms. We've got 2x minus 3x, so that's negative x, plus x over 9, so I think negative 8/9 x. And then the next one will be just x squared over 27, because the other parts cancel each other out. So that should be our final result here. Hopefully I've done that correctly and haven't made any silly errors along the way. Okay, the next one, I'm trying to find a set of values satisfying the inequality, okay, where we've got a positive constant. Okay, so I'm just going to make it maybe a little bit more room here, I think is probably helpful. Everything always seems to take a bit more room than I expect. Okay, it doesn't want to move. Move. Okay. I don't know why everything's on a go slow, but there we go. So the first thing we're going to do is we're going to square both sides. So we're going to go x plus 2a. We're going to square that. It's greater than 3 squared, which is 9, into x minus a all squared. So let's work that out. That's the left-hand side. And then we get the other one, it'll be 9x squared minus 18ax, I think. And then plus a squared at the end. Now at this point, I'm going to gather everything over to one side. So when I do this, I'm going to get 8x squared minus 22xa, or ax I should say, plus 5a squared. It's less than 0. Okay. Now all I'm going to do at this point is I'm going to chuck that into my quadratic formula. So I'm going to go x is equal to minus 22a, so positive 22a, plus or minus the square root of negative 22a all squared, minus 4 times 8 times 5a squared, all over 2 times 8. And what do we get? Well, let's have a look. We're going to get 22a over 16, which is like 11a over 8, plus or minus. Now, under the square root there, what do we get? 22 squared, take away 22 squared, take away 4 times 8 times 5. So we end up with 324a squared under the square root all over 16. Okay, we'll take, this is very messy guys, I probably should leave more room, shouldn't I? This will give us 11 over 8a, and square root 324 is, what is it? 18. Plus or minus 18a over 16, or we could actually, instead of saying 18a over 16, I guess we could say 9a over 8. So 9a over 8. And this gives us two values, 20a over 8. That's when we add 20a over 8. Now 20a over 8, we can divide both of those by 4, so it's 5 over 2a. So that's that one, 5 over 2a. Now if we take the 9a away from the 11a, so that would become 2a over 8, or 1/4 a. So those are our two roots. Now let's just sketch our diagram. If those are our roots, we've got something like this going on here, because it's a positive x squared graph. So if we want everything to be less than 0, we're looking at this range here. So I would just say 1/4. So this is 1/4 a here, and this is sorry, my mistake. What am I doing? I'm really tired this morning, guys. Okay, if we draw that again, those are our roots. So we've got a root at 1/4 a, and we've got a root at 5 over 2a, like this. And we want where this graph, or this function, is less than 0, which is in between those. So we write that as 1/4 a is less than x is less than 5 over 2a. And we're done on that one. Okay, what a debacle. Okay, so the next one, we're trying to do solve this equation, and you notice that hopefully when you see this kind of thing, you should be thinking immediately, look, the addition rule for cosine. So for the addition rule for cosine, we can rewrite that as, why is my trigonometry here? I think on yours that comes a little bit later. I meant to do a logarithm question, so that's somehow disappeared off. Where is my logarithm question? Oh, it's gone all the way down here for some bizarre reason. Let's do it in order so we don't get all confused. Okay, we'll come back to that in a second. Okay, we've got to solve this equation, and we've got to give our answer correct to 3 significant figures. So probably what I'm going to do first is I'm going to rewrite this as ln 5 minus e to the minus 2x equals 1/2, so I divided both sides. Now I can rewrite that then both in terms of ln. Okay, now I can remove the ln's. at this point, I'm going to rearrange everything a little bit. So I'm going to go 5 minus e to the 1/2 equals e to the negative 2x. Hopefully this is making sense so far. Now the next thing I might do is perhaps rewrite that, so you are thinking carefully about what it means. Then I'm going to times both sides by the e to the 2x, so I get this. Then I can get e to the 2x by itself. Now at this point, I'm going to go over to this next column. I'm going to do ln of both sides. Minus e to the 1/2. Now that will give me 2x on the side equals ln 1 over 5 minus e to the 1/2, and then I can get x by dividing that whole thing by 2. And when I do that, I'm getting negative 0.605, and that would be my answer. Okay, so the next one that I'm looking at here is actually the trigonometry one we just talked about earlier. So we're using the cosine addition rule here. So I can rewrite that as cosine x cosine 30 minus sine x sine 30 equals 2 cosine x. Now what I'll do is I'll bring the sine x across to one side, and the cosine x is all onto one side. Now what I'll do is I'll factorize like that. Then I'm going to divide both sides by sine x, so I get all over sine x. Sorry, not sine x, sine 30. That leaves me with sine x here. Then I can divide both sides by cosine x, and that will leave me with tan x on the right hand side, right? So I'll get cosine 30 minus 2 all over sine 30. And that will be equal to sine x over cosine x, which means I've got tan x on that right hand side. So I can now say tan x is equal to cosine 30 minus 2 all over sine 30. And so x is equal to inverse tan of that whole thing. Now you want to make sure obviously that you're set to degrees for this one. Now what do we get when we do that? I get negative 66.2. That's what x is for me. And just so I'm allowed that one because my range is between negative 180 and positive 180. And so to get my next one, because the period of a tan graph is 180, so I just add 180 to that, and when I do that, I'll get my other one. So in this case, that will be 113. Okay, and you can think of it like, if you just imagine your tan graph here, here's 0, goes like this, here's 90, and then it'll go, and there's 180, okay, and so and here's negative 90, so you got one at negative 66. If you just shoot up 180, you're going to get the next one here, so that's that. Okay, hopefully that makes sense to you. Let's move on to the next one, which we're requiring some implicit differentiation. So you did a little bit of this in class with Ms. Ng for teaching this. So what we're going to do, you can see that we've got a product rule is going to be required here. This bit's a little bit easier on the right hand side. So remember the product rule is u dv dx plus v du dx. So we take the x and then we need to differentiate the y cubed bit. So then we're going to go y cubed d dx, and then equals, oh sorry, not equals, plus, now we're going to take the y cubed bit and then apply d dx, or differentiate with respect to x there. So that's that side. We've got a bit more work to do. And then the other one, we're going to apply d dx to this side. Now, as you were taught in class for this, you actually need to apply the chain rule. So you can rewrite d dx as d dy multiplied by dy dx, and you can see that we've got a cancel here, and that leaves us with d dx. But this enables us to differentiate with respect to y. So my next line, I'm going to write that instead of y cubed d dx, I'm going to write d dy times dy dx plus y cubed, and I can now just differentiate that x because it's with respect to x, so that's just 1, so that drops out. And then this 5 ln y I can write as d dy, so I can differentiate with respect to y times dy dx. Now I'm ready to do some differentiation. So the next line, I'm going to differentiate that y. Y cubed becomes 3y squared. So I can rewrite this whole thing as 3xy squared times dy dx. So I've just got rid of this guy by differentiating with respect to y. And then plus y cubed equals, now I'm going to differentiate 5 ln y with respect to y. And that's, what is that, 5 over y, isn't it? So 5 over y, and that gets rid of my d dy. So, and then I've just got dy dx. My next step is I'm going to bring all of the dy dx's over to this side here. So I've got dy dx minus 3xy squared dy dx, and then I can factorize that side. So I can write it like 5 over y minus 3xy squared, and that's all times dy dx. So at this point, I can get dy dx by itself by dividing both sides by the bracket there. So I should get dy dx is equal to y cubed all over 5 over y minus 3xy squared. And now I want to know the gradient at the point 0, 1. So 0, 1, I can now use the gradient function. So this is my gradient function. Okay, it's going to be equal to, now what's the value of y? 1, so 1 cubed, right? This 1 here, all over 5 over 1, which is just 5, isn't it? Minus, now 3 times 0 times 1 squared. So we end up with 1 cubed over 5, which is just 1/5. And we're done. The next one, we've got an equation that's rearranged. No, I think that's something else here. There we go. That's better. Now we're on the numerical solutions. We've got to show that there's a root between 1 and 2. So if we call this equation fx, so we can see that f1 gives us -2. And we can see that f2 gives us +4, I think. And then we can say there is a sign change between x equals 1 and x equals 2. Therefore, the root lies between these two values. Okay, and you kind of understand, I'm sure you can figure out why this is. So if you've got a cubic graph like this, let's draw a better one than that. And let's say this is 1 and this is 2. You can see at 1, you've got a negative value here, and at 2 you've got a positive value, so there must be a root between them, because it must be crossing the x-axis at some point there. Alright, let's move on. Now we can rearrange this formula in the form of x equals fx, where fx is blah blah blah. Use the iterative formula suggested by this rearrangement to find the value to 3 decimal places. So what I'm going to do here is I'm going to say x1 is equal to 1.5, and I'm going to pop that in my calculator and press equals. So 1.5 equals, and that's now stored as my answer. And then I'm going to type into my calculator cube root ants plus 2, and then I just press equals 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 to get all of my values. So let's go ahead and try that. So go 1.5 equals, that's now stored as answer, and then I go cube roots, so where's my cube root button there, answer plus 2 equals. Okay, so my next answer is 1.5183. And then I'm going to go x3 equals 1.5209. And there's x4 equals 1.5213. Then x5 is equal to 1.5214. x6 is equal to 1.5214. Looks like we're getting pretty close. I always do a few more just to make sure. It's going to take very little time to do a few more, and you don't want to do too few because then you won't get the mark. I'm just going to do one more. It definitely looks like we've actually settled. I'm writing to 4 decimal points because I want to find the value to 3 decimals. So therefore, the value I'm going to give is 1.52123 dp. And that is that. Well, I hope that's been helpful to you, team. Hope it makes sense. Let me know if you've got any questions, or if indeed I've made some mistakes, which is highly likely. Until next week, God bless.